7.6 Exponential Functions Part 2 is all about geometric sequences. Geometric sequences are when we have a multiplying pattern, and that gives us the function a of n is equal to a times r to the n minus 1 power. The n stands for whatever term you're looking for. The a is the first term in your list. The r is your common ratio, which means what are you multiplying by? Okay, we're going to use that the rest of the day, but first let's talk about being able to figure out the common ratio for the given sequences. All right, so 2, 4, 8, 16. They're telling us these are geometric, so what are they multiplying by to get these? Okay, well, to get from 2 to 4, it looks like I should be able to multiply by 2, which happens to work for both, so that's all they're looking for, and then we're going to use that to get the next three terms. 16 times 2 is 32, times 2 is 64, times 2 is 128. Okay, the next sequence that you have on your paper is 2, negative 16, 18, negative 54. The only way to switch between positives and negatives is to multiply by a negative. And in this case, I'm multiplying by, sorry, this is a 6, not a 16. Multiplying by a negative 3. So my next three terms would be 162, negative 486, and positive 1,458. Okay, and last but not least on this page we have 80, 20, 5, and 5/4, which appears to be dividing. However, we don't want to say that we have a dividing ratio, so we're going to say instead of dividing by 4 that we are multiplying by 1/4, which would give us the next three terms of 5/16, 5/64, and 5/256. Okay, now we're going to write the rule for these specific geometric sequences, remembering that our function rule looks like this. All right, so because these are multiplying by 3, and my first term is a 1, that's for my a, so I will have a of n is equal to 1 times 3 to the n minus 1 power. Okay, my a for this term is 5, and my ratio is multiplying by 2. So I will have a sub n is equal to 5 times 2 to the n minus 1 power. And then here, I'm multiplying by 1/2. So I will have a of n is equal to 50 times 1/2 to the n minus 1 power. Remember, when you're just writing the rule, the n will stay in n because we don't know which term number we're looking for. Okay, now we're just going to do one of these, and I'll let you work on the second one yourself, but they want us to evaluate, which means to actually solve something. The first one that they give us is a of n is equal to a negative 3 times 4 to the n minus 1 power. They want the second and fourth terms, so we have to plug in a 2 and solve it, and then a 4 and solve it. So if I plug in a 2, I have negative 3 times 4 to the first power, and negative 3 times 4 is negative 12. Then if I want the fourth term, I have negative 3 times 4 to the 4 minus 1 power. So negative 3 times 4 to the third power. 4 to the third is 64 times negative 3 gives me negative 192. All right, just to compare the two types of sequences that we now know about, the rule, if you remember, for an arithmetic sequence was a of n equals a sub 1 plus n minus 1 times d, d being your common ratio, and you always had to look for your 0 term. The geometric sequence that we learned today is a of n equals a times r to the n minus 1 power, and you are always looking for your first term. Okay, so we just need to decide if these are geometric, arithmetic, or neither. Our first one looks like it's subtracting 3, subtracting 3, subtracting 3. So we have an adding negative 3 pattern, which makes this arithmetic. The next one looks like I'm adding 2, then adding 1, then adding 2, then adding 1. And even though that's a pattern, it's not a common ratio or difference, so this one is neither. And then at the bottom, I'm multiplying by 3 every time. So this is a multiplying pattern, which makes this a geometric sequence. Now a couple word problems just to show you how to use this. You drop a ball from 1 meter, which is 100 centimeters. Each path is 45% of, which means multiplying, the previous height. So now that we know it's multiplying, we know it's geometric, and we're going to write a rule. So a of n is equal to the first term times the ratio to the n minus 1 power. Our first term, because we're talking about centimeters, is 100. Our common ratio is 45%, which as a decimal is 0.45. So here's our rule. Okay, that's the first part. Now the second part is to figure out the 10th bounce, so that's going to be our n. So 100 times 0.45 to the 10 minus 1 power. 100 times 0.45 to the 9th power gives us a total of 0.076 centimeters on that 10th bounce. Okay, same idea here. On the first swing, a pendulum swings through an arc length of 80 centimeters, so that's your A. On each successive swing, the length of the arc is 76% of the length of the previous swing. So that makes our rule, A of n is equal to our first term times what we're multiplying by every time to the n minus 1 power. And if I'm looking for the 6th swing, I plug in a 6 for the n, and I get a final answer of 20.28 centimeters. Okay, you should now be able to finish this full assignment, page 450, page 454, and the lesson quiz.